With a hammerhead-like head and a star-shaped beak spanning nearly 360 degrees, this shark is one of nature's most bizarre success stories. It's also one of the most ferocious predators in the ocean. Welcome to my channel. Today, we will unveil the secrets of the weird shark whose head looks like a hammer. Don't forget to subscribe so you won't miss new episodes. The head of this shark is not only odd-looking, but also very functional. The head, or cephalofoil, is specialized for hunting. It has 2 upward-facing eyes at the front and 2 lateral eyes facing forward. And these 4 eyes are all different. The frontal eyes face forward and see clearly whatever is in front of them. Meanwhile, the lateral eyes look out to the sides. Thanks to this, the shark can see almost everything around it without blind spots. Their eyes are large, which allows them to gather as much visual information as possible about the environment. They are able to see tiny details such as the outlines of fish and the movement of tentacles. This helps them find prey and avoid predators. In addition to its vision, the shovelhead also has some other sensory abilities. It uses its nostrils to smell blood and other chemicals in the water. This helps it find prey from far away. Nostrils are located at the tips of their heads and stick out like fingers. It's like a shark version of a finger to smell. Also, if you touch the shark's head, you'll notice something unusual: a bump right behind the eyes. It's not a bump, but several bumps. They are tiny capsules containing jelly-like substances. Together, they form a structure called the ampullae of Lorenzini. These capsules are connected to receptors that react to weak electric fields. The shark releases a weak current from its head and then reads the distortions in the current caused by the surrounding objects. With this, it can sense the presence of prey even when it's buried deep in the sand. For example, a shovelhead can detect the heartbeat of a stingray hidden in the sand. The shark's skin around the ampullae of Lorenzini becomes numb so that the electric field created by the heart of the stingray can be detected. In addition, it's been suggested that these receptors help them navigate and keep track of their orientation while swimming. But why does the hammerhead need such a huge head? Because it's a predator and it needs to constantly look for food. If the shark's head were small, it would need to turn frequently to scan its surroundings. But thanks to its large head, the shark can look around without turning. When the hammerhead swims forward, it scans the surroundings like a submarine equipped with radar. It also reduces the blind spot and gives the shark better depth perception. In addition, the wide head helps the shark maneuver quickly in shallow water. After all, many hammerheads prefer coastal waters where they can hide from large predators like killer whales and tiger sharks. A wide head also comes in handy when attacking prey. When the hammerhead attacks prey, it anchors it with its head. The 2 side lobes of its head press against the seabed, fixing the prey. At the same time, the shark bites off a piece of the prey with its narrow muzzle. The huge head also has another advantage. The large surface area of the head generates lift like the wing of an airplane. This allows the shark to swim effortlessly at a constant speed and conserve energy. According to research, the optimal size of a hammerhead head depends on the depth at which the shark lives. Sharks living at depth have larger heads because they need to move less when scanning their surroundings. One would think that such a large head would make it difficult for a shark to swim, but it seems that evolution has taken care of this issue. A study conducted by the University of Western Australia has shown that the hammerhead doesn't waste much energy on its head. As part of the study, scientists conducted experiments in a water pool. They pulled the sharks along a straight line while measuring how much force was needed. It turned out that for a shark to swim at a speed of 2.2 meters per second, only 1.47 newtons of force was required. Surprisingly, this is comparable to the amount of force needed to pull the head of a great white shark weighing about 2,000 kilograms. Scientists believe that the hammerhead's head reduces drag while swimming. The elongated head minimizes resistance when the shark moves through the water. Also, the shark has a flexible spine that can bend in different directions. This allows it to adjust its body position and reduce drag. In general, the shark's ability to maneuver quickly and efficiently is facilitated by its large pectoral fins. These fins are located directly behind the head and take up a huge area. Scientists estimate that the pectoral fins of the great hammerhead can reach 1.8 meters in width. But not only the head of the hammerhead is unusual, its skeleton has many peculiarities. If you dissect a shark, you will see that its skeleton consists of cartilage, like all other cartilaginous fish. But here's the catch. Cartilage is weaker than bone. So why do hammerheads not need a skeleton to support their bodies? It's all about their lifestyle. You see, hammerheads don't grow very big. The largest species, the great hammerhead, reaches a maximum length of 6 meters. On average, it weighs about 900 kilograms. That's 3 times heavier than an adult male polar bear. The average weight of most other species of hammerhead is about 45 kilograms. For comparison, the great white shark, which can reach 7 meters in length and weigh over 2,000 kilograms, has a skeleton made of bone. Large size requires support, especially since the great white shark actively swims at high speeds. In contrast, hammerhead sharks prefer to move at slow speeds. They spend most of their time cruising in search of food, covering no more than 2 kilometers per hour. Occasionally, they can accelerate to 46 kilometers per hour, but only for short distances. Therefore, their cartilage skeleton is quite strong enough. But hammerhead skeletons have one curious feature. The vertebral discs of these sharks can move relative to each other, allowing for bending and twisting of the spine. In this regard, the spines of hammerheads resemble those of snakes rather than typical fish. Scientists have figured out that the flexibility of the spine is associated with the structure of the skull. In particular, the occipital region of the skull is fused with the first vertebra. In most other fish, there's a joint between the skull and the first vertebra. In hammerheads, the joint is located between the second and third vertebrae. Scientists have hypothesized that the unusual location of the joint causes the vertebrae to move relative to each other. Perhaps this flexibility allows hammerheads to perform sharp turns. The thing is, the greater the curvature of the spine, the sharper the turn the shark can make. Besides, this flexibility makes it easier for hammerheads to swim in tight spaces. The way hammerheads give birth is also unusual. All sharks give birth in a peculiar way, but hammerheads stand out even among them. Most species of hammerhead sharks are ovoviviparous, meaning that the eggs hatch inside the mother and the pups are born live. But the great hammerhead is viviparous. Its embryos receive nourishment not from the yolk, but from the mother's body. There can be up to 40 pups in one litter. Now imagine 40 miniature hammerheads, each with a huge head, chasing each other in the womb. It's hard to imagine a more unusual sight. And no, there aren't 40 heads in one womb. Each fetus has its amniotic sac. The gestation period lasts about 18 months. When the pups are ready to be born, the mother contracts her abdominal muscles, pushing the pups out. There are 9 known species of hammerhead sharks. They range from the smallest, the bonnet shark, reaching a maximum length of half a meter, to the massive great hammerhead. This is the largest species. Its scientific name is Sphaernomalamola. This species is found in both the Atlantic and Pacific Oceans. Great hammerheads inhabit tropical and subtropical waters at a depth of up to 350 meters. They prefer continental shelves and slopes, but despite their enormous size, they are practically unknown to science. Only a few individuals have been caught by deep-sea fishing nets. Scientists know very little about them, including their lifespan. It's estimated to be about 20 years, but it's unclear whether these estimates apply to the great hammerhead. This species is currently listed as critically endangered. One of the reasons is the destruction of coastal ecosystems where young hammerheads live. Another reason is accidental capture by deep-sea longline fisheries. We still know surprisingly little about hammerhead sharks, especially considering that they've been around for over 20 million years. They're believed to have evolved from ordinary hammerhead sharks. And who knows, maybe one day they will surprise us with something else. What do you think? Write your thoughts in the comments. And don't forget to subscribe. See you later.